Now I want you to take a minute and look at this slide. Look carefully at how I first factored right there in that step, and how I rearranged the terms in such a way that you can see where I'm still getting used to this, where the rate changed from positive to negative. If you look, once you get to 18,000, the rate of change in the population is going to go negative. So that makes the limit of the population 18,000. If you remember at the beginning of this recording, it stated that the population started at 4,000, and we've just shown that it will never go over 18,000. You need to remember that the population will never go negative. There will never be negative people. It then asks for what values of P is the solution increasing, decreasing, and justify your answer. The solution is increasing when everything that we factored previous on the page, which you should be taking notes, everything we factored previously shows us that it will be increasing between 4,000 and 18,000 and decreasing when your population is greater than 18,000, because it's going to necessarily, from 18,000, your population is going to decrease. Then we get to this interesting part about when is your solution curve concave up and when is it concave down. Your solution curve is concave up when P is less than 9,000. And I just realized that I didn't show the math there, so let me pause the recording and go to that real quick. Okay, hopefully I'm doing this right and you can see that now. 0 equals 3 minus P over 3,000, and you solve and you get 9,000 as your inflection point. You can double check and make sure it changes signs at 9,000, but it has not asked you to prove that it changes signs there. It just asks you to show where it's concave up and where it's concave down, and what I've shown is, in fact, enough justification. Again, you have a point of inflection at P equals 9,000, because that is where your second derivative equals 0, and when P equals 0, the sign, I don't think that should be there. What is that doing there? There's gremlins in the mix. Okay, we're not going to skip it. All right. Oh, yeah, that's true, but this isn't part of your domain, so that's not important. Oh my gosh. Okay. You can see below what a logistic curve should look like, and then some exploration into what happens if P of 0 equals 10,000 and if P of 0 equals 20,000. If P of 0 equals 10,000, it's starting pretty high up on that curve, and it will always be concave down. So not only would it not have a point of inflection, it would also always be concave down. Now, on the flip side, if you started above the population, let's just say you put 5,000 elephants on Galveston Island, or on Sanibel Island, or on Mackinac Island. Not only are those climates not very conducive to elephant thrivingness, but there are also too many elephants per square foot. So very quickly, you would have overpopulation and a quick decrease in the population to below the horizontal asymptote.